Hello and welcome to the next lecture of multi-degree of freedom system, in which we are going to discuss the topic of flexibility influence coefficients. So first of all, in any vibrating system we have mainly three elements, that is spring, mass and damper. So for spring mass system, that is undamped free vibrations, the flexibility, that is the reciprocal of stiffness matrix, it plays a very important role, and we are going to discuss that particular part in this lecture only. So in last lecture we have derived the equation of motion for a multi-degree of freedom system like m x double dot plus k into x is equals to 0, where m is the mass matrix, x double dot is the acceleration, k is the stiffness matrix, acceleration vector we can call it as, and x is a displacement vector. So what is flexibility? The flexibility is equals to, it is the inverse of stiffness matrix. Say flexibility matrix is A, so we can derive this A as the K inverse, or vice versa. To derive this particular equation of motion in terms of flexibility vector or flexibility matrix, let's multiply equation 1. So multiply equation 1 by matrix or inverse of a matrix K. So it will be K inverse into M x double dot is equals to plus K inverse K x is equals to 0, where K inverse is the matrix A and K inverse into K is identity matrix. So this equation will be matrix A into M into x double dot plus I into x is equals to 0. So from this method we have derived equation of motion into the terms of flexibility matrix. So according to vibration, what is a flexibility matrix? So flexibility matrix is given by A11, A12, A1J up to A1N, A21, A22, A2J, 2N up to so there will be some another row like A1, AI1, AI2 up to AIJ and AIN. So that will be, so particular this vector is a flexibility matrix, and we have to derive or we have to calculate all these coefficients in this flexibility matrix, and we are going to study the influence of all these flexibility coefficients on the equation of motion. So to derive this flexibility coefficients, we will assume we'll consider an example. So let's consider an example like so suppose there are two masses having motion in positive x direction. Let these the springs having spring coefficients of k1 and k2, and let the displacement of m1 is x1 and m2 is x2. So in flexibility matrix, basically Aij is given as the deflection of point J due to deflection of point I due to unit load applied at J, or Aj can be defined as deflection at J due to the unit load applied at I. That is, suppose a line on which we are having 2 points I and J. So the deflection at I, when there is a unit load applied at point J, the deflection due to that unit load is called as the flexibility coefficient Aij. Alright. So according to these definitions, Aij and Aji are the cross influence coefficients, and Aii and Ajj, that is the deflection of point I due to the unit load applied at the same point, are called as direct influence coefficients. Now we will go to our example, that is a 2 degree of freedom system in which there are two masses are moving in x direction and are attached to a spring of coefficients k1 and k2 respectively. So in this example, we have to calculate Aij, that is the deflection of point I due to the unit load applied at point J. So to derive that particular coefficients, we will again draw this example as so. Suppose this is point 1 and this is point 2. So for this particular example, there will be matrix A will be given as A11, A12, A21 and A22. So here A11 is the deflection of point 1 due to the unit load applied at point 1. A21 is the deflection of point 2 due to the unit load applied at point 1. A12 is the depletion of point 1 due to the unit load applied at point 2, and similarly A22 is the depletion of point 2 due to the unit load applied at point 2. So at first, suppose there is a unit load at point 1, that is unit load, and due to this there will be some deflections. So this deflection will be A21 and this deflection will be A11. So we will draw the free body diagrams. So this will be K1, that is K1 and K2. So K1 into A11, there will be K2 into A21 minus A11, and there is a unit load 1. The free body diagram of mass 2 is similar load, that is K2 into A21 minus A11. Alright, so there will be no any other force. So let's write the equation of equilibrium. K11 into A11 minus 1 minus K2 into bracket A21 minus A11 is equals to 0. That is equation number, let's write it as 3. K2 into bracket A21 minus A11 is equals to 0. So from this equation we can call it as A21 is equals to A11. So the equation number 3 was K1 into A11 minus 1 minus K2 into A21 minus A11 is equals to 0. So as A21 was equals to A11, hence K1 into A11 minus 1 minus 0 will be equal to 0. Hence K11 into A11 is equals to 1. Hence A11 will be equals to 1 upon K1, which will be also equals to A21. Also let's again assume the load at, or the unit load at point 2. So there will be a unit load, this is 1 2. So there will be deflections like, so due to load applied at point 2, so it will be A1 2 and this will be A2 2. So let's write the equations of equilibrium, or let's draw first free body diagram. So that will be K1 into A12, there will be K2 into bracket A22 minus A12. So there will be unit load and the opposite force will be the same as K2 into A22 minus A12. So the equations of equilibrium will be K1 into A12 minus K2 into A22 minus A12 is equals to 0. Suppose this is equation as 4. K2 into A22 minus A12 is equals to 1. So here A22 minus A12 will be equals to A1 upon K2. So let's substitute this equation or this value into equation 4. K1 into A12 minus K2 into bracket 1 upon K2. So it will be equals to 0. So A12 will be equals to 1 upon K1 because K2 and K2 will get cancelled out. So let's substitute this value in this equation. So A22 minus 1 upon K1 is equals to 1 upon K2. So A22 will be 1 upon K2 plus 1 upon K1, which will be equals to K1 plus K2 upon K1 K2. So our flexibility matrix will be A11, A12, A21 and A22. So it will be 1 upon K1, 1 upon K1, 1 upon K1, and this will be K1 plus K2 upon K1 K2. So if we substitute this value into our equation of flexibility, so we can calculate the frequency or the natural frequency for that particular multi-degree of freedom system. So for any multi-degree of freedom system, by this way we can calculate the flexibility matrix and we can solve the particular problem by using the flexibility coefficients. Alright, so we'll stop here, and in the next lecture we are going to study the stiffness influence coefficients. Alright, thank you.